Hello and welcome to our 21st AWS Meetup from our user group here in Vienna. Unfortunately, we still have to hold this event virtually, but we're all really excited to see you in person again. So anyways, for now, we're happy to announce two great speakers with really interesting topics. We will introduce them in a moment, but first, thanks a lot to my co-host Bernhard, who will try to save his voice today, so I will mainly take over the moderation.
Yeah, thanks, Linda. I catch the cold, so I really try to save my voice a little bit. But Linda will guide you through this evening today, and will moderate today's AWS meetup for you. Anyways, I'm very happy that we have another chance to talk about cool stuff in the cloud, to come together and talk about those topics. Looking very much forward to have a beer with you and with all of you and the AWS community once again in person as soon as we have the chance to do so, and do a little bit of networking and just exchange thoughts like we did in the good old days before Corona and COVID. So I'm looking very much forward to this moment. Until then, we'll stay virtually to just make sure everyone is safe, of course. But thanks, Linda, for taking over today, and I just hand over to you now.
Thanks a lot, Bernhard. Yeah, before we start, I will quickly give you an overview of what to expect today. So we will have two presentations. We will start with the presentation of LocalStack in about 5 to 10 minutes. So we will wait until people come to our YouTube live stream. So I hope everyone has the live stream by hand. And yeah, so really happy to have you all here today. The talks will last about 30 minutes. And yeah, we will take questions from the YouTube stream, so feel free to post your questions there. And we will have a short Q&A about 10 to 20 minutes. Yeah, so perfect. Then let's start in some minutes. Before we will start, Bernhard, do you have some things that you would like to share with the community, maybe about the reInvent, because it happened like some months ago? Yeah, do you want to say something before we start? So waiting until the people come to our live stream.
Well, I'm looking very much forward to the things that we heard about in the last reInvent. So all the cool announcements that will come this year, or that were just announced but not implemented yet. I'm looking very much forward to things like this carbon footprint tool, that you really can have a look on your carbon footprint that you leave if you use AWS services. So this will be a cool game changer, just also for the mind of everyone, to just make yourself aware, like, okay, I'm using AWS serverless technologies. So what does this actually change for my my carbon footprint? So this is one of the big changes I'm really looking forward to, and I'm very excited about, and all the other cool stuff. There's so much I can share. There's so much I want to talk about, and so less time to do so. But Linda, what's your highlights basically on the reInvent? Is there something that you say this is the most, or this is the cool things you just remember about reInvent?
Yeah, so first of all, like everything that came up around AI ML technologies, so those are really cool things. We also talked about the highlights of reInvent in our community channel here. It's on the same YouTube channel, so if anybody is interested on that, please check out our recap. But one thing that I didn't mention so far, because you talked about sustainability and carbon footprint, what I'm really looking forward is the new pillar for the well-architected review. So we are also doing well-architected framework reviews, and there will be another pillar of that is concerning about sustainability. So yeah, I'm really looking forward to add this also to our interviews, and to have a look on how sustainable the architectures here in the cloud are. So that's really something that I'm really curious about.
Yeah, that will be really interesting to see, basically. To just get it kind of formulated in kind of a pillar, not just talked about, but really as a part that you can put your architecture on, and create your architecture around it. This will be very interesting. But one of the things that in reInvent was announced that I already tried out. I mean, it's just a personal experience thing that I share now, but it was the Graviton support for AWS Lambda functions, and it was like you can change to Graviton processors, which are 30% faster and even cheaper. And I just switched some Lambda functions, and it's really easy and very cool. So basically, All the runtime is supported. You just have to switch the architecture and you save money and you're faster with your serverless functions. So this is really a cool game changer. And it was so easy to switch those things, and just tried it right after the reinvent, and it's really awesome. So if you didn't try this yet, just make sure to have a look at it. Change to Graviton processors for your AWS Lambda functions. It's really cool. You get 30% more performance out of it, just like with one click or so. That's awesome.
That's really cool. Sounds interesting. Yeah, so
Yeah.
I think we can put Waldemar on the stage to quickly introduce him and have a quick chat, and then we'll start with the first presentation. So yeah, welcome, Waldemar. I'm really happy to hear your talk today. So just a quick introduction before we start our quick chat. Yeah, Waldemar is the co-founder and CTO of LocalStack. He and his team are building the world-leading platform for local AWS cloud development. Yeah, prior to founding LocalStack, Waldemar has led several lead engineering and management roles at international corporates, including Atlassian, IBM, and Zurich Insurance. Yeah, Waldemar, happy to have you here. So how was your day? How are you? From where are you presenting today?
Yeah, thanks. First of all, thanks for having me. It's great to be here today. So I'm presenting from Vienna, actually. So from the Vienna office of LocalStack, in fact. So we are we're a small but growing company with a global team, but we also have an actual physical presence in Vienna. And part of our core team is based here, and we have very strong ties to the city. So it's great to be here, especially in this setup here. So how am I feeling today? Quite excited about the talk. So, been going through some of the demos that we want to show. Hopefully the demo gods are going to be with us whenever I'm going to show the live demos afterwards. But yeah, super excited to be here and looking forward also to the Q&A, the questions from the audience afterwards.
Perfect. Then I think we can start. So as soon as you share your screen, we will remove ourselves from the stage. And yeah, Waldemar, the stage is yours.
Awesome. Thank you so much. So I'm going to share my screen. All right. I hope you can see it now.
Perfect.
Yes, sir. Okay, perfect. All right, just start this slideshow here. Yeah, so again, so it's great to be here. So again, my name is Waldemar, CTO of LocalStack. So the title today is Turbocharge Your Local Dev Loops for AWS Cloud Apps. And it's really great to be here and share some of the exciting stuff that we do at LocalStack with you today. And also, as I mentioned, it's going to be sort of interactive in the sense that I want to show some live demos and hopefully everything will work out well. But I think we have a nice setup there. Yeah, so just a brief overview of the agenda. So just giving some background about what the project is about, then really diving into a quick start demo, how you start and use LocalStack locally, then talking a bit about integration. So how does LocalStack integrate with things like Terraform, CDK, and other tools. We also want to touch a bit on some advanced usage and features that we've recently started developing and been focusing on. So one is called Lambda code mounting. We're also working on EC2 containers and a feature that we call local cloud pods. And then finally also give a very short sneak preview of what we call the LocalStack cockpit, which is a user interface on your desktop. And then obviously in the end, a wrap up with Q&A. Okay, so just to set the stage, just real quick, and I'm sure a lot of you will be familiar with the general story, but today the cloud is simply amazing. It has given us a lot of opportunities to really build scalable applications, like basically incredibly scalable applications with a very low footprint of sort of the pricing side and like really low capex costs for the team. But on the other hand, like from a dev perspective, sometimes things can be a bit slow, tedious, and costly also. So if you think about a typical day in the life of a cloud developer, you have to manage all sorts of different resources, things like databases, virtual machines, message queues, and so on. And then what you end up doing is like doing a lot of deploy cycles where sort of you deploy a change to the cloud, make some tests, is everything working correctly? Maybe not, so you have to redeploy. So it's kind of slowing things down a bit if you have these cycles. The other aspect is kind of remote debuggability. So looking at things like CI builds. If you have a red build in your CI pipeline, it can sometimes be hard to figure out what was actually the root cause. there's barely any ways to do things like memory inspection or stack traces that you can get from the cloud environment. So it's easier to have these things locally rather than the cloud. And also, if you think about the Git flow or team collaboration, where you have lots of team members operating on different branches, feature branches, oftentimes teams end up creating, one environment per feature branch or one environment per developer, which can be sort of quite sort of a high overhead for the DevOps teams and high maintenance. So that's why at LocalStack, what we provide is what we call a fully functional local cloud stack, which really allows you to develop your apps locally and even offline if you have the right setup. So it really enables a very efficient dev and test loop for your cloud apps. The way it's packaged and shipped is as a Docker image, so you can easily just sort of download the Docker image, install it, and start it up. And we have support for various different APIs, things like Lambda functions, EC2, ECS, and others, database systems like DynamoDB or RDS, messaging, and also some more sophisticated APIs like QLDB and some others. So if this was a real sort of in-person event, I would probably ask, show of hands, who's been using LocalStack before, who's heard about it. Fortunately, I can't see the audience here right now, but I'd be curious to hear that afterwards as well, because I think it's already a quite popular tool in the AWS community. However, what I'm going to show you is sort of that the project has also evolved quite a bit since the last couple of years. So kind of the very high level view is that, as your application is moving through different stages, so from the local developer machine through a CI/CD system all the way into production, your blue box, which is your application, is just talking to different API endpoints. And on the local machine and in CI, these can be provided by LocalStack, right? By our emulation framework that provides the same sort of functionality as the real clouds. And then finally, you make the switch and deploy it to production. So we really focus on this pre-prod step here in the development phase. Now you might want to ask yourself, and that's kind of a topic of also heated debates, like why local, right? So I mean, obviously you have the ability to reproduce your application in the state locally. So giving you a lot more ability to do things like debugging, quick iterations and cycles on your sort of test and deploy. So speed and ease of use is definitely a high factor. Also, sort of the debugging capabilities tend to have like higher quality, right? Because you can replicate bugs locally, find them quicker and easier, and also obviously reduce management overhead because you don't need to create AWS dev accounts. One thing that we often hear is from some of our users and customers is these removed restrictions for regulated environments. So if you happen to be working maybe in a insurance company or bank, sometimes it's hard to get access to the real cloud. With LocalStack, it's just very easy because you can essentially, don't have to go through the approval steps for getting access to the real cloud. Simply, spin up your Docker container and you're ready to go, basically. There is some interesting discussions here on Hacker News, which I would sort of recommend you take a look at when you have some time, really kind of seeing a few of the pros and cons arguments and like very interesting discussion here. Probably going to link that after the talk. So just a brief word on the history of the project itself. So we started out as an open source project a couple of years ago, and we can broadly say that there were like three main phases. So the first phase was a bootstrapping phase, and what you can see here in this chart is the number of GitHub stars over time. The first phase was really just bootstrapping, getting the first functionalities out. There was a tweet by Jeff Barr, who's the chief evangelist at AWS, and he kind of really. So that was when sort of the initial sort of bump was happening in the adoption and the GitHub stars. Then there was this early adoption phase where sort of new features have been added, but sort of still sort of slow growth, but some early adoption of users. And then really sort of where things are now kicking off quite dramatically is in the last 6 to 12 months, where we now have a team that's really working on this full time. And LocalStack today is also very different from what it used to be in the past. So if you maybe used it in the early phases, I would encourage you to take another look today because things have been dramatically improved. And in general, I just want to give kudos and also shout outs to everybody who's been involved in the development, so the open source contributors, but especially also the core team who is working day and night to make this really such a great product. So really big kudos for that. Just a few numbers on sort of how frequently this is being used and the growth. So again, as I mentioned, it's turned from a project into a successful company. We can see that the GitHub commit frequency is definitely increasing over the last 1 to 2 years, which is great to see, especially in the last couple of months here. And we are talking about a usage of approximately 300,000 downloads of the Docker image every day. So that's quite a significant usage there. And again, as I mentioned, we have significant improvements in the last couple of months. Things like the startup time has been reduced from roughly 10 seconds to like a second, essentially. There is a new plugin mechanism. We have multi-arch builds, so we can now also support Apple M1 and ARM64 architectures. We have advanced persistence support, a refurbished web user interface, and just a lot more that's coming out of this engine out of LocalStack. Okay, so I'm really going to switch real quick because I think that's really what you maybe also are interested in kind of how to actually use this this tool. So I'm going to switch here. So what I have is prepared a couple of samples here that I want to go through with you. So the first one, what we're going to do is we're just going to start LocalStack here in this terminal window. So you see it starts up, and we're just going to run a couple of commands to just see and get going with the framework. So what we're going to do is we're going to create an S3 bucket on the local machine. So I'm doing AWS local, which is an alias or like a wrapper script around the real AWS CLI, which allows us to run commands against the local instance. And you can see that it's created the bucket here. We can then also create a file with some content. We can upload that file to the bucket. We're going to do an S3 copy, and then we can do a list on this bucket which is created, and we can see, okay, it's there. So basically, the hello world example has succeeded here. We can also create an SQS queue. Create a queue with a name test queue1. Send a message to that queue. Right, I'm just going to copy paste the command here. So we just send a message hello world, and then we're going to receive that message from the same queue. And you print out the queue. So this is really sort of the very basics of how you interact with the stack. So this AWS local command, as I mentioned, is basically the same CLI interface as the real AWS CLI, but it just contacts the local instance, which is running on port 4566 by default, and that's all happening within your local instance here. Okay, so that was really sort of the very simple hello world example. So just did that, started up LocalStack and ran a few CLI commands, create a bucket, create a queue, put a message on the queue, and so on. So that was the easy part. Now, what we see generally, like LocalStack is a highly configurable system. So there is different configurations for networking, for example, port configurations, Docker networks. So there's lots of sort of plug points and sort of moving parts that you can configure. There's also service-specific configurations. For example, you can configure the latency of certain services. You can also inject errors, for example. Then there's Lambda configurations, which is very special. We'll show that in a minute, where it enables you to do things like local code mounting. You can define the executor mode and other things. There's debug settings like verbose logs, debug ports, and so on, persistence settings. So a lot of different configurations. You can look them up in the docs here, so I encourage you to take a look at that. But generally, we try to just take sensible defaults for most of the things, and you can then sort of, if needed, configure them manually. But typically, things work out of the box quite nicely. But again, the docs are a pretty good place to look those up and get some more information. Right. So the next part is the web user interface, because the CLI usage is great, but some of our users are also interested in having a visual experience. So what we're going to do here real quick is take our switch over to the view of the web user interface. So this is the app.localstack.cloud. I'm logged in with a demo user here, and what we see is so the first part here is a very simple usage dashboard where you can see sort of the key metrics, how many, which resources have been created, like how many times, and sort of how many events have been recorded and so on. So that just gives you like a bit of an information about sort of how the instance has been used in the past. And then we also have a resource browser here. We'll take a look at that in a second. And then we also have this quick start guide, and I just want to give sort of a quick overview and deploy a sample applications right here from this quick start. So we have an application provided here, and I'm going to click here. So what this application is going to do is basically a sample app that deploys. Actually, before I do that, I'm just going to deploy it right away, so we can keep this off in the background. So it should now start. Yeah. So now the browser has created the request to deploy this application. I'm just going to quickly show what this application does. So we are here with the user's web browser. So this is what we currently look at. And then the sample application deploys an API gateway locally. And this API gateway is connected to a Lambda function, which takes the request from the API gateway. It then puts these requests to an SQS queue. Then there's another Lambda function which reads off individual items from the SQS queue, puts them on a step function state machine. So those workflows that you can configure with individual steps that are connected. And the step function consists of two steps. The first one is another Lambda function that is just processing the request and updating the state in DynamoDB. And the second step is an archiving Lambda, which, as we call it, which simply puts some result to S3 and also updates the state in DynamoDB. So it's a somewhat synthetic example. So, but it's a very common pattern that you see in a lot of serverless applications, right? You have some API gateway that takes a request, and you have some asynchronous processing logic, and then the state is kept in DynamoDB, and that's all happening sort of in your LocalStack instance. So switching over here, this has now been deployed. So essentially, this is deployed as a CloudFormation stack. And what we can now do is directly from the browser, we can sort of create a test request. So what this does is it actually should be sending a request to this API gateway here. Just a sec. If it has been deployed properly, I'll just go back here real quick. Okay, now it's there. Right, so now it's actually sending this request to the API gateway, and it's basically now going through this processing step, right? So the Lambda, which we can see, is getting invoked here. So there's lots of logs, obviously, that you see, but basically the screen parts are Lambda invocations. So the Lambda is getting invoked. It puts the item on the SQS queue. There's another worker Lambda that gets spawned, and then the step function. And what you can see is that down here, we actually see the updates from the status. So now with this timestamp, the request was in status queued. So basically got added to the SQS queue, and the state was updated in DynamoDB. And then as a next step, it should get picked up by the worker Lambda, right? So now it's the state processing with this timestamp. So now this this processing Lambda has picked it up. And then finally, we should see this archiving Lambda, which is then sort of putting the final result to an S3 bucket, which we should also be seeing. Yep, so now it's finished with this timestamp, and the final result can be downloaded from S3. Again, S3 as in on the local machine. And if we just look at this file here, we see archive result for request 9434, and that's exactly the request ID that we got here. Right, so this was kind of illustrating like one end-to-end flow of, again, like very typical example of an application that has an API gateway, some Lambda functions, some backend processing, SQS queue, step functions, and so on. It's kind of nicely illustrating how the request is being processed here in the instance. Okay, so I hope that was clear so far. I'm gonna switch back, stop the auto refresh here. And switch back to the slides. Yeah, so this was the web user interface, and just starting the slideshow again. Yeah, so that was what we just looked at, the web UI and the sample app. So we deployed the simple sample app and browsed the local deployed resources. Actually, that's another thing we can briefly look at. So now that the application has been deployed, we can actually use our resource browser here, and this is kind of similar to what the AWS console is providing, obviously like a very simplified version of that, but you can see now the Lambda function that we created as part of this sample application. We can see the S3 buckets, for example. We can drill into the files in here. We can take a look at maybe where's the API gateway? Just taking a quick look. API, I'll find it in this list. many services here already. Can't find it right now. But maybe you can also take a look at, yeah, CloudWatch logs gives us the indication logs from the Lambda, so we can actually drill into this and see how the Lambda has been invoked. So I guess you get the point. It's like really just a simple way to interact with the state of the instance and get you know, quick insights into what's happening inside your LocalStack instance. The other interesting point is actually CloudTrail. So CloudTrail is sort of tracking events that are happening within the instance, and also CloudWatch metrics. So for example, we saw AWS Lambda function names, and we can actually see some of the CloudWatch metrics. Right, so again, like the UI side of things is more for the visual usage, but a lot of people just prefer also working with the command line interface or the APIs themselves. Okay, so gonna switch back here to the presentation mode, also being a bit mindful of the time. So I think we're doing well with the time so far. It's been 15 minutes. So the next thing I want to briefly talk about is integrations. Integrations are really important for us because we want to meet the developers where they are. So really fitting into your existing ecosystem of tools and services that we can sort of integrate with. So we support things like infrastructure as code tools like Terraform, Pulumi, and I think we'll actually have a second talk where we will also cover some of this definitely in more detail. We have language SDKs, things like JUnit, Python, and other integrations. Developer tools like the CDK, the Cloud Development Kit from AWS. We'll take a look at that in a second. And also things like the Serverless framework, for example, Thundra, which is a sort of observability platform for your Lambda functions, all the way to CI/CD systems, all the major ones that are provided to really enable you to easily run your CI builds with LocalStack. So that's really important for us. Integrations are really key. The first one I want to quickly talk about is Terraform. And again, there will be more details in the second talk, I'm sure. But basically, it's an infrastructure as code framework by HashiCorp, where the resources are defined in a declarative way. And then Terraform creates a plan, which is then applied to create the resources in the real cloud environment. So essentially, this is what it looks like. So you have some practitioner, as HashiCorp calls them, or some DevOps person who's creating this infrastructure as code scripts. Then a plan step is happening, which is kind of comparing the state of what's currently deployed in the cloud to what should be the target state. And then apply is actually applying the changes required to make this work and to converge to the target state. The next thing, yeah, and also we have like very easy integration for Terraform with LocalStack. So what we're going to do is in this quick demo here is going to look at a simple Terraform script and see how it deploys on LocalStack. So I'm going to switch back here to my samples, and you can see sample number 2, which is a Terraform script. So first of all, you see the provider section here at the top, which has the endpoints for all the different services. So they're all port 4566 on localhost. For S3, we're actually using a host name because we can then leverage the host name-based bucket addressing. And then you see a bunch of resources. So we define an S3 bucket, we define an SQS queue. This one is commented out because we don't need it for this demo. We also have IAM roles and policies, and a Lambda function, which sort of refers to one of the zip files, which is also part of this directory. And then we have an event source mapping that basically connects the SQS queue that was defined up further above to the Lambda function. So what we're going to do is we're going to go to the sample 3, I think this was. And then what we're going to do is essentially, first of all, we're going to do a Terraform init, which is basically initializing the local environment, the local directory, downloading plugins and everything. And then we're going to do a Terraform apply, which then sort of looks at the current state of what is deployed in the instance. Currently, it's empty, so there's nothing there. And then it proposes a plan of what actions to take, right? So it's creating all these different resources. So I'm just going to put yes here. And then it's creating those instances. And the next step will be to send a message to the SQS queue, because remember what we had in our example was an SQS queue that is connected to a Lambda function with an event source mapping. So if we send a message to the queue, we should then see a Lambda function being triggered in the local environment. So again, now it's been deployed successfully. That's great. So we're going to send a message to SQS. So the message was sent, and now we actually see, I got to scroll down here, and now we see, oh, hello from LocalStack. So the Lambda was actually called from that SQS queue. We can also then take a look at the log stream, because the invocation of the Lambda actually created a log stream. Or at least, maybe I got this wrong. Demo effect. I took the wrong name there to a list on the list log streams. Sorry, the log group name is part. I think we first need to look the let's describe log groups. Okay, so maybe I'm actually in the wrong. Yeah, so demo effect, but essentially usually what works is what happens is that the logs that created as part of the invocation of the Lambda that was triggered from the SQS message. So that part we're going to skip, but basically you typically see the logs then appearing. Might also be that there's a region mismatch in my demo here. I'm not sure what happened there. Cool. Okay, so that is kind of the integration with Terraform. So what we saw is a Terraform script that defines all these resources. We have the provider section that points at the local instance of LocalStack, and then sort of we have the apply step, which really sort of creates the instances locally. You can see this up here with the apply complete, and then sort of we can interact with these resources locally. So that was the sort of the integration part for Terraform. So I'm going to switch back again real quick to the to our slide deck here. The next thing I want to really talk about is the CDK, the Cloud Development Kit, which is something that's very actively being developed and pushed by AWS. It's very popular to define your infrastructure as codes. It basically has different bindings for different programming languages. You can code in Python or TypeScript or Go or other languages, and then so basically you define your infrastructure in these languages, and then CDK transpiles them or compiles them into a CloudFormation template, which then gets deployed in the final instance. So this is essentially what the workflow looks like, and AWS CloudFormation is also provided in LocalStack, so you can use all of the CDK sort of functionality also natively in LocalStack. So again, demo time, as you might have guessed. So what we're going to do here is we're going to have a CDK example that deploys an AppSync application. So AppSync is a very interesting API actually that is using GraphQL to define schemas for queries and mutations, and then allows you to access different sort of backend data sources like DynamoDB, for example. So the application we're going to create is creating a DynamoDB table and a GraphQL schema, and then we can actually, from a client, run queries against this AppSync application. So I'm again switching here to my sample number 4, and just a quick look at what we have here. So let's take a quick look at the actual CDK example. So this is what a TypeScript CDK stack looks like. There's quite a lot of code in there, but basically what it contains is a GraphQL API, which is called Items API, and we have a GraphQL schema which has queries where you can get all the instances or one particular item, and you can do mutations, which is a save operation or a delete operation. And then we have essentially what is called resolvers, which are basically the mapping from the data sources, like our DynamoDB instance, to the actual GraphQL operations. So here we have the data source and then the corresponding resolver, which basically has the mapping of what the request to DynamoDB should look like. So again, what we're going to do here, and I'm just going to really quickly do a restart here of this instance, go to my sample 4. And then what we're going to see is, okay, and then in my script here, sorry for sort of jumping between the windows, but it's the first step we're going to do is we're going to run CDK local bootstrap. So this CDK stack contains assets, which means that we need to run bootstrap first to initialize the environment, the local environment. CDK bootstrap is now running certain bootstrap actions against the LocalStack instance. You can see this here in the log outputs. And once the bootstrap is finished, we can do CDK local deploy. And again, CDK local is just a small wrapper script around the real CDK CLI. It's just sort of pointing the local endpoints to localhost. So we're deploying the changes here. And again, so the mechanism is always the same. Like the client application CDK here is talking to the APIs and sort of it doesn't really care about sort of where they run, right? It's on a local machine, but it just appears to CDK as if it was deploying it against AWS. So now it's been deployed. So what we're going to do here is now we're going to do an AppSync list GraphQL APIs because we want to see which APIs are there. So we see, there's one API that was created. Perfect. That's the one we want to work with. We're going to get the API ID, just extract it from, just going to use a JQ here to extract the API ID. Then we're going to get the API key itself. So as part of the deployment, an API key has been generated, which can then be used to access the API. And now we're all set for actually running these GraphQL queries against the instance. So here we'll see that we first run a mutation query, and I hope you can actually read this. Might be a bit small for you. We're going to run a mutation query which runs a save operation with name test1. So that's just going to add a new item to DynamoDB, and we run this request against this instance. So this is literally a GraphQL AppSync endpoint on your local host that you can use to run AppSync GraphQL queries. So you're going to run this. What's happening is this sort of quick round trip. So it's now basically, AppSync has received the request, it has extracted information, has made a call to DynamoDB, and it's actually returning the response back to the client. So we get the result here. I'm going to run this second time just to extract the item ID from the second item, and then we can do the reverse operation, which is a query. So first we did a mutation operation, and the second one is a query where we retrieve this one item that was just added before. So we're going to run this here, and it's going to give us back this exact item that we were expecting. So again, we're doing the round trip from AppSync to DynamoDB and all the way back. Okay, so apologies for kind of rushing through the examples quite a bit because we wanted to make sure that we can cover a lot of different aspects of LocalStack. So I'm going to switch back again to this. We saw, okay, CDK works quite natively with AWS. And with LocalStack, so we have this CDK local wrapper script that basically runs the request against your local instance, and you can run quite complex and complicated and quite advanced applications on your local machine. All right, so the next thing I want to briefly touch upon is the topic of Lambda hot reloading, because especially in a local dev environment, we want to have very quick feedback cycles and be able to make changes in our code and immediately see what sort of the impact and the change of the impact of these changes was. So we provide a mechanism that is called code mounting or hot reloading, where you can specify a special bucket name for your Lambda function that is called __local__. So that's just a placeholder that we use. And then as the S3 key for your Lambda code, you can point to a directory in your file system. And then essentially this directory in the file system gets mounted into the container, and you get sort of this hot reloading mechanism. I think this will become quite a bit clearer again in the demo time. So the only thing that's required here, and that's actually the default setting, but you can also explicitly set it to say lambda remote docker equals 0. So that's one of the configs that required for this sample to work. And then we deploy a function with this local bucket and with the S3 key that points to the current working directory. So I'm just going to, again, switch over here to our sample as before. So that's now sample 5. I'm going to go to my IDE real quick. Sample 5 is here. So the Lambda function itself is a Python in this case. So it's just a simple, just printing out hello from LocalStack. And the run script is also quite simple. So you see that we're doing a create function here, function name hot reload. And then this is not a critical part. So we specify as the code location. The S3 bucket is __local, and the S3 key is the current working directory, right? And the rest is just standard definition of the Lambda function. So I'm gonna run this here in the terminal, and you should then be able to see. Okay, so it's been deployed. And now I can do an invoke on this Lambda function, right? And we should then see this in the output here. Cool, we see hello from LocalStack. And now the idea is to have these really quick feedback cycles. We want to make a change in our code. Hello, AWS Vienna Meetup. Right. We're going to save this file, run another invocation here, and it should immediately take effect without having to do any sort of redeployment, anything of that sort. You can also extend it then, for example, if you want to, maybe use case is to list the S3 buckets where you want to just, list what are the current buckets deployed in the instance. If that's our use case, you can just enable this in the Lambda function, call it again. And now in the output, we actually see, we have a bucket here with this name CDK toolkit. That was the bucket that was created beforehand. So you see, it's like very easy to kind of have these really quick cycles where you just add a bunch of code, you make some changes, and then it's immediately reflected in your environment. The other part is obviously the debuggability. If you want to set breakpoints, we also have some nice use cases on how that can be achieved. All right, so want to be a bit mindful of the time, but I think maybe one more quick demo should hopefully be fine. So that's another very exciting topic that we've sort of recently been working on and are about to launch. So in the serverless world, Lambda functions are pretty popular, but there's also a lot of users who are using still like EC2 containers to deploy their applications, just if it's more long-running tasks or maybe some heavy lifting, heavy computation. And we have basically two ways to enable running EC2 virtual machines on LocalStack. The first one is like actual virtual machine hypervisor. We use VirtualBox for that, and we have a sample application that we can be happy to link out. It's part of our sample repositories. Using VirtualBox is a nice way, but it's kind of also a bit heavyweight, so it adds a bit of additional requirements to your machine. So that's why we also have the second option, which is to use Docker containers to run or to emulate EC2 virtual machines, right? And that's obviously a much more lightweight option. It runs natively on Docker, has less dependencies, but it still integrates nicely with some common popular build tools like Packer.io or Ansible or others. And that's what I just also want to quickly show here. The way you can enable this is by EC2 VM manage equals Docker. So that basically enables this Docker mode. And what we're going to do is we're just going to sort of create an instance, SSH into the instance, and then also create an image, like a snapshot image from the instance. So again, switching back to my terminal here. So again, one thing that's important, we need to start it up with EC2 VM manage equals Docker. So I'm going to just append that to the startup configuration here for LocalStack. And then I can quickly switch over to our sample number 6, which is this one. And so first of all, what we do is we use a certain standard for naming of Docker images, which is basically so every Docker image that starts with the name with the prefix LocalStack EC2 is basically considered part of these EC2 containers, right? So all these images can basically be used, and they have a tag which basically corresponds to the AMI ID, which is then used in EC2, right? So EC2 has this concept of AMIs, which are the identifiers for the images, and we just use sort of Docker images to represent those. So that's the key idea here. And what I'm going to do here is now really quickly do an EC2 describe instances. So describe instances, again, this is like a call to the EC2 API, which is now returning us these 4 images that we saw in our Docker instance. So, the system sort of believes or gives you the impression that you have these AMIs available, even though there's essentially Docker images. The second part is we're actually going to run an instance from an existing AMI. So we're going to do EC2 run instance with this one image ID. And what you can see here is that in the background, it's actually now spawning a Docker container, right? So if you do a Docker PS now here, and there's actually one from before, I'm just going to remove that real quick. Wasn't the clean environment before. But the one that you're now seeing, this is the one that was created 14 seconds ago. This is now literally sort of the EC2 instance, quote unquote, that's running in Docker. So what I can now do is I can SSH into that instance. And SSH is really important for a lot of these build tools to have the ability to SH into them, and voila, we're in there. So we can make some changes. We can, for example, create a file here, hello world, disconnecting from this again. And what we can now do is actually, in addition to having this instance running, we can now create a snapshot from it. So what we're going to do is we're going to say, first of all, I need to get the instance ID. Just look that up from here, and then we can create a snapshot with the create image command. We're going to call this snapshot2. And what this now does is, again, it takes the current running container, and it's now created this snapshot image here, which can then sort of be used again under this AMI ID to spin up a new EC2 instance, essentially. So that was sort of this part, which is pretty excited about, like, having the ability to spin up EC2 instances in a very lightweight fashion, just sort of as Docker containers. And we really believe that this can be quite a game changer for local dev as well. Okay, so I need to be a bit sort of mindful of the time, and maybe if the organizers can give me a sign if I'm getting too much out of time. But just a very quick sneak preview of one other thing that we have in the making, which is what we call the LocalStack cockpit. So this is an Electron app, because like what you've seen, there's lots of configuration options, and some people just prefer to have an easy way to spin up the LocalStack instance. So what we provide here is essentially a graphical user interface that allows you to interact with the instance in a really easy fashion. So once the cockpit actually starts up here, it gives you basic information about sort of what Docker image you currently have on your instance, and you can do things like creating profiles where you can set, for example, environment variables that you want to set in your config, right? So that's something we can actually configure here. And then you can use this to start and stop the instance. I'm just gonna start it now, which should then, in the background, we do a Docker PS here. It's gonna start up the instance. Yeah, you can see it starting up here. And once it's started, we can actually get things like the logs of the instance. We can take a look at the services that are currently available. Right, so you see all the services that are kind of available. We can get the logs from the instance. So this is just a very sort of useful way to interact with LocalStack, and we're sort of planning to extend that by quite a few more features once we launch this in the next couple of weeks. So really looking forward to getting your feedback as well on this piece. All right, cool. So I'm really sort of wrapping up, maybe 1 or 2 more minutes. So I'm not going to have the time to demonstrate this to you for time reasons, but we also have this new feature that we call Cloud Pods, which basically is a persistence mechanism. So you can take a snapshot of your current instance, you can store it in a backend, and then sort of inject it into some other instance. So basically, you can use this for things like collaborative debugging, where 2 people are working on the exact same application state by using these Cloud Pods for sort of collaboration purposes. And again, I'd have a demo about this as well, but I'm afraid that we're running a bit out of time. So that's why I'm going to sort of wrap it up with sort of what we've been seeing here, and also the motivation and feedback we get from the customer is sort of this increased efficiency and agility through the local development. Also the ability to work in regulated environments with restricted access to the cloud. So maybe you want to get productive with maybe bootstrapping your cloud development or your digital transformation journey from an on-premise into a cloud world. But you're facing these cloud approval processes. For that, it can be very useful to use LocalStack. Rapidly experimenting without the risk of breaking production is obviously a big point of it. And also involving new developers and remote teams into sort of the dev cycle without having to access the real cloud. And ultimately the cost savings, but that's maybe not the most important part. I think it's more about the other benefits it brings to the table. Right, so then I would like to close with just try it out, please. Reach out to us, engage with our community. There's some great documentations online for you to get started, how to set up and configure your instance. You can also set up for a free trial of the Pro feature that you saw before in the app. We also have some free educational licenses if you happen to be a student or some nonprofit organization. And then really sort of engage with us in Slack. So we have a very active Slack channel where we communicate with our users. We'd love to get your feedback. We really want to understand how you use it, like what kind of pain points you're facing, and really where you see sort of the future of cloud dev from local to hybrid to sort of real cloud, and really across the entire life cycle. So with that, I think that's pretty much concluding the presentation part, and I'm really happy to take any questions and have some discussion with you.
Thank you so much, Waldemar, for your presentation. It was really, really interesting, and I would love to try that on my own, and I will in the near future. And yeah, we have some really cool questions on YouTube, so the community is really great here. We will take a look at the first questions. So I hope you can see the question now. Perfect. Yes, this works.
You read it for you as well, Waldemar. So how long does it usually take you to catch up to new service releases or changes in existing services or APIs?
Yeah, that's definitely a great point. So one of the things that obviously keeps us busy, so AWS is very active with pushing out new features, but I think we've sort of settled on a sort of set of core APIs that we're supporting. It's actually a very large number already, with a lot of the compute services, the database services, and some of the more exotic ones, like the ones you mentioned, for example, with, I don't know if it's like new instance types, like Graviton, or maybe some AI, ML topics. So we don't really jump on all the different topics. So it's really, for us, it's more solidifying the current experience for the services that are already there. And sort of in the past, we used to be a bit more proactive. So when new sort of feature requests were coming in, we used to tackle them. We're now trying to be a bit more proactive and really looking at sort of what's the surface area and what do we actually want to cover, and sort of be a bit more proactive about the roadmap and what we're delivering in our releases. Yeah.
All right, we got another question.
Yeah.
With the EC2 instance containers, can you mock instance connect too?
Yeah, so this is still a bit sort of in the making. We're now working on actually SSM integration, where you can actually send commands to the instances via the SSM interface. Instance Connect is definitely one of the next things we're going to be looking into. Again, it would be super useful for us to understand your use case, like how do you perceive this to be used? Do you have any specific examples? Please reach out to us, because it's really sort of very much in the early days. We're a few users who are using it already, but we're really happy to learn sort of what your use case is there. And I think it's a great opportunity for also integrating the different build tools that are out there to really enable these local EC2 instance containers. So yeah, please reach out on Slack or GitHub as well, if you can find us there.
Great, that's cool.
And there is another question.
Yeah,
Sorry,
we have 3
Linda.
questions left.
That's awesome. Would it be possible to get a snapshot from prod to local debugging?
Yeah, so that's actually a great question. So I think we did have one of the slides, but we had to skip it for time reasons. So definitely one of the things we're looking into is, so starting from an existing prod or staging environment, like how can we get like a representative copy of that into the local environment? So it's currently essentially a set of scripts where we go through the services, go through the resources, and we essentially inject them into one of these cloud pods. And once they're in a cloud pod, they're really easy to share. You can store them in some backend. You can share it with your team members. So definitely, it's one of the next steps of the evolution of this cloud pods journey. We really want to make the transition like from prod. It's not only from local to prod, but also from prod to local, and want to make this really seamless and really a good experience for users. Yeah. There's more. How much time do we have left? Do we have time for another one?
We have still 5 minutes left and 2 questions.
So we can achieve this. So the next question, Cockpit looks great. Is it able to provide some basic stats too?
Yeah, so that's definitely. So I think I'm not sure if this is sort of more related to the user side. So yes, the cockpit itself is mostly looking at the current LocalStack instance. So it's not really looking at any historical data or information. What you saw in the web UI that I was briefly showing the dashboard, that actually also contains some historical data of how the instance has been used. We don't currently have this in the cockpit. We're actually planning to migrate a lot of these web UI functionality also in the desktop version, because we see that a lot of people are just preferring to download an app and just run it locally as opposed to using this web application. So definitely that's something that will be part of the next evolution of the cockpit as well. Mm-hmm.
Cool. And the last
question.
There's
one more question. Yeah. There's one more question. Very interesting demo. Are those samples, use cases you have shown today available somewhere for download?
Yes, absolutely they are. So we have a bunch of GitHub repositories which contain some sample applications. There's one called, in the LocalStack organization, there's one, for example, called, I think, LocalStack Pro Samples. So that's a great resource to look at them. Also our docs.localstack.cloud is a great starting point. You can browse through the services. They usually have pointers to the sample applications. So yeah, definitely. We also try to sort of make them more accessible over time as we're sort of ramping up also our DevRel activities. On
this point, I can just add something. Waldemar, if you let me get the samples you showed today, I can provide them, or we can provide them to the community in an email or so we can reach out and send everyone the examples and your slides if you like to share them. So we can send them out to the whole community if you like.
Definitely. Yeah,
that's a great idea. And we also have some fans in our community. So I will just quickly show some other comments that are not questions. So Christopher says that this is an amazing project. And also we have somebody that says it's been a lifesaver for them that they are using LocalStack. So I think that's really, really cool. And I appreciate the support from the community.
That is super amazing. And also maybe just one word because Christopher is one of our active contributors on open source. So again, like it's a huge effort from everybody, and just big kudos and shout outs to everyone involved to really make this possible really in the end. Really cool.
That's really cool. So Waldemar, is there something that you would like to say for the last minutes, and then we will hand over to the next talk?
Yeah, so again, like thank you for having us here. I think it's a great opportunity, and maybe hopefully not the last time we had a chance to talk here. So definitely, I think what I was trying to show today is maybe again, like some of you may have used LocalStack in the past couple of years where things were working somewhat okay, but like just to give you I hope that this presentation was giving you a bit of an outlook into what's going to happen. Like there's a lot of innovation currently going into the platform, and it's actually quite amazing what can already be achieved today, and we have quite high ambitions of where we want to take this. And really, it's something where we want to work with you and see where you are. Also having like a very active dialogue where you think, you can push local development that far, but you cannot go farther than that. So really hoping to have some, good active sort of engagements, also discussions in the community to see what are best practices and patterns, and where do you go from local to sort of hybrid and into the cloud. So yeah, just really super excited to get your feedback, and also in the various channels that we have, especially in Slack. So it would be great if you all join our Slack channel.
Sure, we will share the links afterwards so that everyone can have all the resources and see all the things that that you prepared and that you showed us. And thanks a lot again. We really appreciate your effort to do these talks and to prepare everything. That's really, really great. And we're looking forward to see you again, hopefully in one of our meetups.
Definitely. Thanks again for having me. Have a great day. Thank you. See you soon.
Bye.
Bye-bye.
Okay, so we're looking forward to our next speaker. We already
excited.
have Sebastian.
There's also great topic coming up. I'm sorry, Linda. Sorry.
It's fine. The delay here is not that easy to cope with two moderations, but that's fine. So, Sebastian, hello. How are you?
Hey there. Yeah, I'm quite good, thanks. Hello, Sebastian, for having me.
Really cool. We're happy to have you.
Yeah, I'm glad to be here. So it was quite a good talk, actually. So, I mean, I'm usually a strong advocate for doing this live, but this really seems like something which I should try.
Well, you're basically live as well, but unfortunately, you can cannot see your audience, But hopefully we can change this in the future, you know, with all this COVID craziness. So
I
yeah,
also hope so.
Yeah, no, absolutely. No, I was actually referring to the talk. So like, you know, like usually trying to like do these like test cycles and stuff like live, like actually deploying the stuff. But there's always this delay, which is bothering me. And so it seems like a good option to try. So I'm certainly looking into this. And should be fairly straightforward since I'm using Terraform, most like CDK for Terraform most of the time. So should be able to plug in there.
Perfect. So yeah, before we start, a quick introduction about Sebastian. So everyone who was at the AWS Community Day or at the CDK Happy Hour probably also already know Sebastian. He's a tech lead for Terraform CDK at HashiCorp and has over a decade of experience in software engineering and technical leadership. Yeah, we're happy to hear your talk about Terraform CDK today, and he will give us an overview about what we can expect in 2022. So, Sebastian, the stage is yours.
Cool. Thank you very much. Yeah. So, yeah, as I mentioned, like as George said, so I'm talking about CDK for Terraform, and I talked about this here and there already, and I think it's probably, well, I'm probably going to start out with like where this project is coming from. That's like really like a rough, fast overview, and then dive into like what we are going to do like this year, like what's more in the roadmap. Touching on this briefly, and then like going like more expansive on this in like an actual demo. And I think it's easier to demonstrate like the things we are going to tackle in the next little while. Yeah, so you can find me on Twitter, you can write me an email if you don't have any questions or whatever. Yeah, let's dive into Terraform, CDK for Terraform. I mean, like most of you probably know AWS CDK, so I think it's pretty clear where this is coming from. It's like the same structure in the end. And so we do support like a bunch of languages to like as an abstraction layer on top of Terraform, like in contrast to the AWS CDK, which does this for CloudFormation. We are doing this like for like your like normal Terraform configuration and encapsulate like all the logic in like either TypeScript or Python or whatever it is in the end. So again, I'm going through this rather quickly. So the rough idea of how this works, like CloudFormation is generated like like for the AWS CDK, for the spec where the AWS CDK is generated from. The same works for the Terraform provider ecosystem. So what you see here is like a synthesized stack in the end, like this like artifact which you would deploy. So the key thing to remember is like when you know Terraform and Terraform HCL, that's pretty much the same representation here, but in JSON format. And that's what we are using here to turn like like an application like consists of stacks and constructs, like this tree of constructs, into like a deployable stack or like a deployable Terraform configuration. So there are various levels which we build upon in the end. Like Terraform CLI is still in the play, Terraform providers are still used. So like we are just a layer on top of the existing ecosystem, which means it plugs into Terraform Cloud and Terraform Enterprise and like various other Terraform tooling which people might use, like like for for auditing, for security reasons, whatever people are doing. Pretty much works for Terraform CDK as well, as long as you use like the synthesized artifacts, like this JSON artifacts in the end. Right. In contrast to the AWS CDK, we only provide like the level 1 constructs. So the AWS CDK talks about like level 1 to level 2, level 3 constructs. And since we do this for like the entire Terraform provider ecosystem, so like there's like more than 1,000 providers, we can't really provide like more abstractions out of the box at the moment. We have some, we play around here a bit with a few ideas how to abstract common building blocks, but like on a provider level, we don't really do this at the moment. However, there are like other ideas which I will come into later on, how to build up like this, like this constructs library for well, like multiple providers, perhaps even, we'll see. But one thing to remember, it's like pretty much like a one-to-one mapping between the existing Terraform provider schema, like an AWS provider, for example. You will find the same resources in Terraform CDK stack. Again, here, oh, I was lying. It was probably, but nowadays it's probably like a bit more than 200, so not 1,000, but like, I don't know, a couple of hundreds. Right, and that's what I was just talking about, right? So like on the left-hand side, you see this is a schema of like in this case the AWS provider, which describes like resources, data sources, and like a bit of provider block configuration. And that's what we are using to generate like the code representation of this, right? So which is then utilized by Terraform CDK and which can use to build further abstractions on top of it. But this is like a fully automated process, and this works for pretty much every provider. So we had like a few issues here and there in the past, but I think nowadays it's pretty much, like a full coverage of features, I think. Yeah, we have like a few pre-built providers. So like, since like, depending on the language which you're using, like if you're like using TypeScript or Python or C# or whatever, it might take a while to generate the provider bindings, like the code representation of this provider in the specified language. At least if you're using one of the larger providers, like the public cloud providers, for example, it usually makes sense to use like a pre-built provider. So this will save you time and effort to build up these code bindings, basically. As I mentioned before, like that's like the CDK, like the cloud development kit itself is like this ecosystem of things, or like of three, perhaps even like depending on how counted, like 4 products, which like have like all the same conceptual ideas and like using like the same building blocks, in particular like JSI and constructs, which is like the binding element between all these different frameworks. But we won't go into the details here. It's probably like more important or like more interesting to talk about like what we're actually going to do. So like the product itself got kicked off 1.5 years ago, and it's like a full team at HashiCorp for pretty much a year, or like a bit more than a year already. So before that, it was just in an incubation phase, and nowadays it's like 4 years, like a full team, like a growing team, which is quite exciting. And well, we spent the last year like doing lots of improvements, like diving a bit deeper into the Terraform ecosystem. I don't know, like building up for production readiness. So we are not exactly there yet, and production readiness doesn't really mean like 1.0, but like to turn off the beta level which you have at the moment. Like you have established workflows, like it's like a robust framework which you can use to, well, I don't know, run your bank on it in theory. And it's important to remember like the actual execution and the actual provisioning is still happening with Terraform, which is like like a very, very proven product. And very established, and so it's like yeah, it's if you like lay on top of this, but still like our workflows are like a bit different to like what the default Terraform workflow might look like. What we are doing right now is like CLI improvements. So the CLI hasn't really improved much or half in the last few months, so that's what we are focused on right now. To and that's what you see, like you see the current version in a demo, and then I think it's pretty clear what I'm like why this is necessary. Also, like in terms of like production readiness, full multi-stack deployment, which is also like a concept which works in AWS CDK. We do have like a partial support for multi-stack deployments, but so we recently got like this cross-stack references. So you have like like an app which consists of like a base stack and like I don't know, like some some child stack, and you want to wire them together. It's also like if you're gonna see in the demo. However, like at the moment, you can't really, just do like a CDK deploy, and then it builds up the graph, like the dependency graph of the stacks and deploys it. So that's what we are doing right now, basically. Also, like to some extent, pays into the production readiness there, and full Terraform HCL feature coverage, in particular, like dynamic features of HCL. Like there's like this dynamic blocks, like iterations, like more advanced concepts, which are not always really necessary in the context where you have like a full programming language available, but still there are cases when you deal with computed resources, for example, which you don't really create locally, but they're like somehow created in the cloud environment. For these cases, there are like a few gaps at the moment in terms of HCL coverage for the Terraform CDK, and that's also something we're gonna address. Custom data sources, resources means essentially, building like custom logic and encapsulating this as like a data source or a resource, and using this while you're planning or like deploying and applying resources. That's something which enables like way more dynamic use cases in the end. And I think that's not really sure when this is going to happen, but it's happening soonish. And I think like the most important part that is going to happen is, I think, like workflows and conventions. And I think, well, whoever saw the talk for the AWS Community Day, I think I was talking about this like cloud-driven development, like having like more advanced cases, like this test-driven iterations, building like actually resembling like the experience of like a local development environment, and however you might achieve that, but it's not really something which is baked in at the moment, neither in CDK for Terraform nor in Terraform itself. It's still like a very disconnected experience, and that's where I'm not really sure like how this will look like, but I think that's like the direction where we're heading, like make it easy to really build cloud native applications. In a sense, cloud native, actually cloud native, and not Kubernetes, right? Like actually cloud native, leveraging managed services and which whatever people or like, but whatever the public cloud providers are providing. To really understand this, let's dive into like a quick example. I put together here. So I hope it's readable, but should be, I think. Make it a little bit smaller. Right. Well, for clarity, let's collapse this a bit. So like I was actually using like an example I had already, and I assembled it to like a little example today, and did like a little upgrade in between, got it working, which was quite good. So what we see here is like a pretty much like a default TypeScript-based CDK for Terraform application, and whoever knows AWS CDK, seen AWS CDK knows like how this looks like. It's like pretty default layout for an application, I believe. So it's like two stacks. We have an authentication stack, we have an asset stack, and this is wired together as an application. And these two stacks are depending on each other, right? So the auth stack encapsulates like a cognito with like a bit of glue lambda code, like a DynamoDB table, stuff like this. And then there's an asset stack with like an API gateway, like an S3 bucket, and like a bunch of glue code again. Doesn't really do much at the moment, but like I think it's good to get the idea across, and also to see like several advanced concepts like beyond like this 101. And yeah, So like that's a starting point. So like 2 stacks and wired together and like one application. And we are using the AWS provider, so like a pre-built provider, so which is just an npm package and like a bunch of other resources and some custom stuff which I put in here. You see, we have like a test layout. That's something which we added last year. So it's like more like on the unit testing spectrum. So I didn't add any tests, but like you could add some tests here. And test essentially like that the configuration is properly generated. Like when you synthesize your application, then and you generate this JSON artifact, then you can say, okay, this contains actually the resource I expect and the configuration I expect. That gets generated out of the box. And also the other stuff is mostly generated, I believe. And what I wanted to see here, right. So let's start here. So we have this like a bit bigger construct. So like constructs are referred to in the CDK world as like the abstraction, like the building blocks, right? So essentially just a class in that sense here. Like the cognitive authentication, where we have like a few attributes here and a bunch of resources. So the resources doesn't really matter. Like what is interesting in this context, that I did build like my custom construct library here, so which brings in like a few features which we think might be like a like a nice building block, like across different providers of the Terraform ecosystem, and like code bundling is certainly one of them. And in this case, it's like the Node.js function, which is like resembling like a bit what the AWS CDK has as a construct as well. So it takes like some code and bundles it up and makes it like a full Lambda function essentially, and you can extend it like a bit. So that's one of these things I've been talking about earlier. So it's not really feasible to do this for each and every provider, and also this particular package here only has like a few resources which I personally actually use. And it's also stemming from a time before we had like another bridge or like another option to have like abstractions for the AWS ecosystem. Since you can imagine, so we can build this for AWS, you could build this for Azure, for Google, for whatever, but it's like a huge effort. So it would essentially be like having like a new provider team for each of these abstractions, and that's not really feasible at the moment. And it's also necessary, in particular, and for like in the case for the AWS CDK, or the AWS ecosystem itself, there is quite a lot of work done by the AWS CDK itself, by the team itself, right? So, oops. And so what we built last year is like the technical preview still, but it's like an AWS adapter, so which allows you to pull in constructs from the AWS CDK and deploy them as part of your Terraform configuration, and actually as Terraform configuration, not as a CloudFormation stack, but as a fully native Terraform resource. And this was enabled by the Cloud Control API. So it got launched, I don't know, like September last year, I believe, and is more or less like what the CloudFormation service uses, internally to make this happen, like to provision resources. I'm not really sure if that's true or not, but that's, I think, the rough idea, that like the same building blocks which are used for CloudFormation provisioning, which means like the API service is exactly the same as CloudFormation for each resource. The downside is, at the moment, it doesn't have a full coverage of the API service of AWS. It's catching up, but it takes a while, so it's not fully there yet. So it's like really just a preview at the moment, and it works like for like a few popular services, Lambda, S3, but for example, Cognito is not part of this at the moment. So it just takes time to catch up there. So that's the reason why I still use this, like this, my custom little library here. And that's also like a concept that you probably would have within your organization anyway, right? So like some custom constructs that's what we are seeing in like from like a few customers, that they actually build like internal applications like with internal abstractions in the way they actually want to configure their services. And it's also totally fine, but doesn't really work as like this like global thing at the moment. Anyway, so but in theory, it's possible to use AWS CDK constructs as part of the stack. Just doesn't really make sense here in this case at the moment. Yeah, and other than that, yeah, I don't know, like normal stuff that you probably expect. And let's just do like a little deployment. And let's start with the OST. So ignore like all the credential injection here. That's the actual command to care about. And oops. So what this does is like it's synthesizing. It's like pretty standard in terms of CDK. And then it's kicking off like a plan behind the scenes. It's actually using the Terraform CLI behind the scenes. You could use Terraform Cloud as like a remote execution engine as well, but I'm just using it as a state store right now. So when you have a look here, you have this remote backend configured, and that's where my state is going to end up. And here we have a plan, and you see already, if you're familiar with Terraform plans or Terraform plan outputs, it's very high level and it looks a bit ugly. It's part of the reason is because I increased the font size, of course, but it's like it doesn't really give away much detail at the moment, which is for an entirely new stack, as in this case, it's probably fine. But if you're looking for change sets, it's like a bit annoying, and that's like one of the things which it's going to be improved, so it will like look totally different. It like gives away more information. But anyway, so we roll with this for now, and then it's gonna apply the resources here. And again, not really much information. And you can imagine this works in this case with like a bunch, I don't know, like maybe it's, I don't know, 10, 12 resources or so. But if you had 50, like 100, this gets very noisy. And that's one of the reasons also like why the CLI UX UI has to change entirely. And so yeah, it's gonna look way different, and I think it's gonna be like way more useful. Since I think like this works like for quick demo case, but like for like day-to-day work, it's like not really the best experience at the moment. And since it's Terraform under the hood, you can still fall back to Terraform CLI anyway. So when you synthesize the output, it's just ending up here, like the configuration, the assets which are generated, like a bit of more configuration. So that's, yeah, so you could just go into this directory and use Terraform and do like a Terraform apply. Would totally work, as long as you have right credentials configured, of course. Yeah, and like one piece which you're seeing here is like this output, which is not part of the stack, but it's generated. And you see this already, like this prefix with this cross stack output. And it's generated because we reference, or we publish, we expose the identity property from Cognito and make it available in our other stack where we reference this. And so we detect this internally and connect them together. And I think it's like a very similar concept again to AWS CDK. Just to make it seamless and, well, make people thinking less about how to connect their different stacks together. And the actual reason why you would have like multiple stacks, I mean, in this case, it's I don't know if it's really like a good reason to have like multiple stacks. But like if you had like long-running resources, long-living resources, databases, network, perhaps authentication, stuff like this, so which is hard and difficult to change. At least it might make sense to have this isolated, like in terms of scope for applying, for changing this, but also like in terms of manageability, refactoring, stuff like this, right? So like keep the scope small and make it easy to change individual pieces without having like huge runtimes, huge plan times, and like lots of risk whenever you deploy something, whenever you touch something. But yeah, so that's one of the things. And I mean, like what I would want is to have like this global CDK TF deploy, and that's also like one of the things which is going to happen soon. So I mean, we have information what depends on what, and so it's gonna be easy. And I think so far, not really exciting. It's like all like mostly catching up on like existing like ideas in the ecosystem. And I think what's gonna really be interesting is like how to evolve this this probably not only the CDK for Terraform, but also like the general CDK ecosystem into like really just having like fast iterations, faster testing, or like no testing at all. Haven't really checked recently on the state of integration testing for AWS CDK, but I know that this hot swapping for Lambda stuff that's there, and these are all pieces which, like for example, hot swapping, that's nothing we have to do since we're using the provider anyway, and it's like using the API endpoints, right? So it's like faster usually in contrast to CloudFormation. But in my opinion, it's still not fast enough. So I would really love to have like more like even faster iteration somehow. Not really sure how to pull this off. But like I think like one of the good starting points would be to have like one integration testing framework, which would potentially not even be limited to CDK for Terraform, but perhaps like like CDK in general, or like perhaps even like totally detached from CDK. I'm not really sure how that's going to work, but that's something which is sort of on the list. And then like this, like this entire like workflow, how to integrate deeply into Terraform Cloud, like make these setups more straightforward. Like there's lots of details when you start to think about like how to make this really seamless, right? So like sort of like the idea I have in mind here is like rates for infrastructure, right? So like lots of conventions and predefined workflows which just work. But yeah, that's probably a long journey, but we are getting there at some point. Yeah, other than that, or did we deploy this? Yes, we did deploy. And then we actually can deploy the other stuff. And yeah, this all worked here. And yeah, it's synthesizing again, like this goes all again from the start here. And there was something I wanted to show. Was there? Take a preview. Oh yeah, here's like there we deployed the auth stuff here. This again, it's just the state storage here at the moment, but we could use you could also use this like to to apply this remotely. So and then you would have credentials here, and like we could in theory connect the stacks together, like the different workspaces together. But yeah, that's all. That's another topic, like deeper Terraform cloud integration in general. And again, a pretty complex plan. And I think we might actually see an issue here. Oh, no. Okay. So I was sort of expecting that this might create like scrollback, but it doesn't. Okay. And yeah, so I mean, deployed, done. And let's go back here. And yeah, I mean, they're like, so the repository itself is like on cdk.tf, and there are like a few learning guides which gets you started for, you know, like trying out CDK for Terraform, like in various languages, and that's cdk.tf/learn. And there's also like a Slack chat, like for the entire CDK ecosystem, which is cdk.dev. And yeah, that's also like a good point to get more information in general. But if it's specific for CDK for Terraform, like I don't know, raising issues probably, you know, like if there's like a bug or anything, then that's probably the right place to go. And that's already it. And we deployed the stuff here. And yeah, so I mean, we deployed a bunch of resources, and you're gonna trust me on this. And here we are.
Thank you so much for your presentation, Sebastian. It was really, really cool to see what you can do with CDK for Terraform. So I think the audience also was really excited to see those demos. So really, really cool. Thanks a lot. And
yeah, sure.
Yeah. We also have one question from YouTube, and then we will do a quick recap about what we heard today. And yeah, so I will show the question now, and Bernhard will read it out loud for us.
Yeah, so how will this work together with AWS CDK? The biggest use case for us would be to use the AWS CDK, but complement it with CDK for Terraform for non-AWS resources.
Let me think about this. So like the question is like to have non-AWS resources inside of the same, well, like the same application, the same AWS CDK application, or is that the question, I assume?
I would understand it this way, yeah. But,
well, like
maybe you can formulate the question a little bit different in the chat. We will read it then.
Well, one thing which is important to understand is like that the bridge is one way at the moment. So it's like not bidirectional. So we can pull in AWS CDK constructs into CDK for Terraform. But well, everything is possible, of course, but it's not like supported by default, you know, to use like CDK for Terraform constructs within like an AWS CDK stack. I mean, you could make it work somehow. There's like, you know, like CloudFormation custom resources with which use Terraform, but I wouldn't go there. In terms of, I don't know, I think the easiest way would probably be to keep both things separated and connect them somehow via like remote resources or like outputs or like, I don't know, like, you know, like SSM parameter store, stuff like this. Like, you know, use this to exchange the data you need to provision like various resources and various targets and keep it like separate. I think like this bridge which we are talking about is really, you know, like leveraging like the abstractions. Like for like one common case which you're actually hearing about is, for example, step functions. Step functions is, writing this by, I've seen people writing this by hand, like the JSON configuration by hand, and that's not a lot of fun, obviously. And more recently, there's the step functions builder, yes, but it's still like sometimes really nice to have it as code represented. And the AWS CDK folks have built these abstractions, so why should we build them again, right? So then it makes sense polyfill these cases basically. But if you're all in on AWS CDK, I would not really try to pull in CDK for Terraform in that direction. That doesn't really make sense. Hope that's clear. Yeah, hope that's clarifying it.
Yeah, so we didn't get a follow-up question about that. So I think it's clarified. Oh, there is. Waldemar also has a question, so we will also show this one.
Yeah, great talk. Thanks, Sebastian. We have different ways to configure cloud resources these days: Terraform, Pulumi, CDK, etc. Do you see things converging to a common community-driven standard?
Well, I mean, in the end, all of these tools are using the same APIs, right? So, like in that sense, there is like some sort of standard already. There are just different ways to manage the workloads, or like to define these workloads, and like a bit difficult, different philosophies behind it. And I mean, it's like, even like when you just look at AWS itself, there are like multiple tools which are targeting the same space, like from slightly different angles. And I think in the end, it's like such a huge market, such a huge space that there's like lots of different type of users who have different requirements. And I think in the end, it's probably not, at least at the moment, I don't really see like a community-driven standard in that sense, beyond APIs. But happy to talk about this, of course.
Maybe we could facilitate this in the AWS community. Sorry, Bernhard. We're just talking at the same time.
Yeah, two people, same idea. No, I just wanted to say basically exactly the same. So it would be really interesting to have this conversation on another level, like with other people involved in those things. I just think about some community leaders from Germany that are very deeply into the AWS CDK development and consulting business. So they definitely have some great ideas to talk about those topics, especially. So maybe let's see, maybe we find a common ground to get some people together and to kind of a streaming event to talk exactly about this, because I think this definitely is something that is getting more and more interesting in the future. You know, you have so much different tool sets out there, so many different ways to achieve the same things, and just to, you know, grow your efforts in the proper directions and to combine forces. This would be definitely an interesting topic.
Yes, I'm certainly looking forward to try it. I mean, I saw LocalStack a few years ago, but haven't really touched it since. But yeah.
Well, Waldemar has a follow-up. It's not a question, but
follow-up comment.
Just a follow-up comment. Yeah. So he's looking forward to continue the conversation on integrating Terraform CDK with LocalStack. So I guess you both should have a talk.
Yes, would love it.
Perfect. That's what we love about the community. So that networking is really working well, and we will also get Waldemar back on the stage to have a quick recap. So Waldemar, nice to have you back here.
Yeah, thanks. It's a great presentation, and I think it's we should really maybe follow up on this and see how the integration could work. Yeah, so it's really great to see sort of how things are, as you mentioned, under the covers, it's all APIs that are getting called, and there's different views on different abstraction levels of how things are expressed in terms of the different infrastructure as code tools. And yeah, really looking forward to discussing maybe more about the integration with how this could work in LocalStack.
Yeah, absolutely. I mean, it's I mean, just remember like this provider configuration. I mean, this would be just like a little construct in the end, and then you would more or less be ready to go. And I've seen like lots of people struggling, in particular in this case where, you know, like they weren't really able to use remote cloud due to restrictions in the organizations. And I mean, you probably know it better than me, but like this workflow of going through pull requests all the time for like a tiny change and iterating on that is quite painful.
Yeah, and just one more, so we were actually quite happy that Terraform added this in the very early days to actually be able to configure the endpoints like these local providers, because that's not something that's always the case, but it's great to see that there is configurations that enable you to use these tools, but also with alternative endpoints, right? And I think that's something that we hope to see becoming a standard pattern for, you know, whatever managed service, whatever you provide. There should be a way for the community to actually start working with it, even if they have local emulators or the local version of it. So it's really great to see the support there from Terraform. And,
What I've been wondering, like, what's the, like, for the supported resources in LocalStack, like, do you have like 100% API coverage there, or is it you know, like just like the important parts for example, like a Lambda function, or like, I don't know, like some queue, event bridge, whatever.
yeah,
you know what I mean?
Yeah, no, definitely not 100%, but we're, let's say, starting to capture more essentially what the percentage is that we are covering for the core services. I think the ones that we focus on, we have in our docs a page of supported services, and there the coverage is already quite good, also with the different CloudFormation constructs, which essentially are the CDK constructs, right? Once you support them. So I think that's really a, let's say, very beneficial for us that CloudFormation is really this almost like this assembly language as they had it on their slide, like the lowest common denominator of how things can be expressed, and then you have all these higher level, you know, programming language constructs basically. But everything boils down to CloudFormation, which makes our lives a bit easier to support it.
Yeah. So does it mean it's just like then like a pass through support more or less, like it's like
yeah,
you mirror, or you pretend to have like 100%, but it's only implemented at like 60, 70, 80% or so, and the rest is just ignored.
Essentially, yeah, exactly. So those resources that are not supported, which is print out a warning message coming soon or something like that. Essentially, yeah. So one other thing that's,
are you tracking this? Like, do you have like, you know, can you see like what people are actually trying to use?
Actually, yes. So we were starting to track this. Obviously, we need to, you know, be mindful of privacy reasons, and we make sure that everything is anonymized. But definitely, that's something where if something's not supported, not implemented yet in LocalStack, we start to track that and have better overview of what's, because then we can see, you know, what is the often requested resources that are not yet supported in LocalStack, and we can prioritize those. So that's definitely important for us. One other thing that we're doing, just to mention, because you're here, we actually use the Terraform test suite. Terraform has like a large, huge, you know, Go test suite of almost like a million lines of code. So we actually use that also as a test suite against LocalStack, and that has been very, very helpful. And you know, as an integration and regression test suite for our own internal development. So yeah,
like the AWS provider test suite, right? That's.
Excuse me, sorry.
The AWS provider test suite.
Right, exactly.
Yeah,
the AWS provider. Yeah.
How long does it run for you?
It times out after 4.5 hours, I think.
Right.
No, I think it's, I think the last run, I think, was like 4 hours or so, and but that's, I mean, it's a massive test suite, and but it's great to see that this is all sort of publicly accessible, and you know, you can just leverage that, and this really drives the innovation forward in a very dramatic way, right? Because now you can, it's essentially the most precise semantic representation of the AWS services out there, right? That's publicly accessible. And if you have parity and you can run all the Terraform tests, that gives you very high confidence that it also works in AWS.
Yeah, that's true. That's true. But then it runs faster for you than it does in real life.
How long does it take in real time?
Not sure, but like longer.
Okay, that's good to hear. Yeah. it's interesting because there's also a couple of sleeps and like basically polling loops in Terraform, because like obviously if you deploy things like a Route 53 DNS configuration, that usually takes some time for the network to propagate. That could actually even be much faster locally. So sometimes these polling intervals actually could be reduced from a testing perspective locally, but we just use the defaults there, and it's also working well.
Yeah.
Cool. Yeah, it's nice.
I have to say, actually, that's one thing I love about this community, is that people are really networking and talking about the things that they love to do, and to keep everything going forward. And I think that's really cool. And to see you discuss about the next topics that you could try, and yeah, also what you already did, that's really cool. So from my side, really thank you a lot for your presentations, for the discussions. Thanks also to the audience for the questions and everything. Yeah, I think we have some minutes left. So if we want to talk about some other topics, yeah, feel free to start something. Bernhard, do you have to say something about the talks, some recap?
I just wanted to fall in line with you. So just thank you for your efforts to present your topics, to put in the effort, and to share your knowledge, to share your experience with those topics. That's highly appreciated. And also thanks for the fruitful discussions you both had right now. This is really what drives the community. So I would love to see both of you having a beer in one of our next AWS meetups in person. So I'm looking very much forward to this happening. But
have you specific plans for going in person again?
No plans so far, but of course, if it's safe for everyone, so we don't want to endanger the health of anyone, but if it's safe for everyone, of course, this is definitely a goal we want to achieve. So have those AWS meetups, again in person, and then use the chance to bring people together and have exactly those discussions with one or another beer.
Yeah. And speaking of beer, I guess we will stop the YouTube live streaming now, so that we can have a beer together and have a quick chat without. Yeah. So thank you a lot for all of the viewers out there, and you can watch the stream also afterwards. So feel free to contact us, to contact Sebastian and Waldemar on Twitter and LinkedIn. I guess that's also fine. We will share the links for all the presentations and the demos afterwards. And yeah, happy to see you again in our next meetup.
Cool.
See you. Thanks again.
Thanks for having me.
Great evening.
Thanks all. Bye.
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 Bye-bye.